Right. So the car is traveling from point A to point B, and we can just calculate the distance that it traveled by, like as s. We are given the acceleration in terms of like we are given the tangential acceleration of the car, and we have to find velocity component and acceleration component in terms of en and et, and we also have to find acceleration in terms of I hat and j hat. All right, so now we begin with the normal component of velocity, which is always zero by definition. And for the tangential component, we just integrate the tangential component of acceleration, and so that we can get vt in terms of vt in terms of time. And now and now we know that we know that the distance that is traveled is just integration of velocity, and so that we can get so that we can get the distance, and we know the distance that it has traveled 278.53, so that we can just set it equal so that we can get time. And once we get the time, we can just plug into the plug into the tangential component of velocity. Okay, so now we got velocity as normal component and tangential component. Now we are to move on for acceleration. We have given, by the way, we have given the tangential component of acceleration. And now if we talk about normal component of acceleration, then we know the formula for acceleration, with the normal component of acceleration, which is velocity squared divided by the radius of curvature. So that we can also get the normal component of acceleration. And now if we want this, and if we want acceleration in I hat and in terms of I hat and j hat, we can simply look at position B, that it is saying that j hat and tangential component are in same direction, but I hat and normal component are in opposite direction. So we have to so basically what we do is we just swap the direction. We just change the direction of the normal component, so which is basically negative 5.57, which becomes negative 5.5708 in x direction, and 0.5 in z direction. I mean in y direction.